All right, morning everyone. This will indeed be a frenzy, and we're going to be going through a lot of different versions of QGIS. I'm going to start out by comparing, let's see, where's my, there we go. Start out with a roadmap. So we're going to start out kind of comparing the current long-term release, 328, and what's new in that since the previous long-term release, 322. So that will include features introduced at 324, 326, and 328. And then at the end, I have a few minutes to cover some of the new features that have come out in the last couple months with 330 and 332, which was just released Sunday or Monday this week, very fresh. So let's start out with comparing what you'll see differently in the new long-term release, 328 FOSS4G. I'm going to go through this kind of categorically, and as a caveat, I don't have time to go through all the new features. That would take a couple hours. I've selected some that I think are most important and some that might be overlooked, convenient features by category. You can always use the visual change logs to read about these features in more detail. And I'd also like to just say at the outset that I'm really grateful to all the sponsors who made all these new features possible and all the talented developers who implemented them. I owe a debt of gratitude to all those. For each slide, I'll have a little banner in the upper right that'll indicate which version of QGIS this feature was released in. So first off, there's a breaking change. So this is important. So they've dropped project backward compatibility just for symbology with QGIS 316 and older. So this means that if you have a project older than 316 with some interesting symbology, you should update that to a newer version of QGIS so you don't lose that. Basically, previous releases of QGIS would write a lot of compatibility objects into the XML structure of the QGIS project file. And so to clean things up, they're removing some of that. So that's why this is a breaking change. So we look at data providers next. So at 324, the functionality from the GPS tools plugin was ported into QGIS Core. So this is appearing now in several places in the QGIS GUI. In the data source manager, there's a GPS tab now, so you'll find the ability to import GPS data there. There's also tools in the processing toolbox, specifically for GPS data. And in the settings window, the GPS Babel settings can be entered. Moving on to this, I'm using here the built-in geocoder, OpenStreetMap geocoder, to zoom into Kosovo, and I've got the XYZ tile service for OpenStreetMap loaded. Now I'm going to add the MapZen global terrain. So these are both now available in QGIS. So for anywhere in the world, you have these two layers available to you. I just created a hillshade rendering of the terrain, used the multiply blending mode, and now I can zoom into Prizren to get a better view of the terrain with the OpenStreetMap data. So this is nice. We have, in the box data available in QGIS now. With the user interface, if you have a graduated rendering, you can right-click on a class now and select the features in that class. So that's quite a nice feature. So any one you right-click on, you'll have that exposed. And you can also do the same with identify features. You're right-clicking on a value and identify features will select those values on the map. So nice little shortcut there. And at 328, this was enhanced. I can right-click again and select these features. Right-click again, and there's show in attribute table. So it will filter the attribute table with an expression that identifies that class so that you open up the attribute table with just those selected records visible. also a nice new feature for when you add delimited text to QGIS. You want to map the points. I'm going to add a CSV as a delimited text file, and you now have overrides, so you can cast the field to the correct format. Oftentimes, QGIS in the past may have misidentified a string as a number or vice versa, so now you can make sure that all those fields get cast to the correct type before you add the data to QGIS. So this slide shows all the different renderers we have by different geometry types. So we have, for example, point geometries, and you have your single symbol, categorized, graduated, etc., those renderers. And then beneath that, we have the symbol layer types, simple marker being the default for points. And so in recent versions of QGIS, there have been some added. At 3.2.4, the line burst symbol layer type was added, and outline line burst. Also raster line and outline raster line for polygons, and animated markers for points. So let's look at these. This is some building outlines being shown with a geometry generator to convert them to lines, and then using the line burst symbol layer type, which is basically like a shape burst fill for lines. And you have some settings there for the join style, but there can be some nice new applications for this. And I think now with symbology, QGIS is a really complete package. It has some incredible options for symbology. This is an example of a hiking path, and I'm using the raster line symbol layer type. Now I'm going to navigate to a bitmap that I have on my hard drive and increase the stroke, which basically just increases the size of that image, and it places it along the line, so you get a nice rendering of the footpath. So it's a couple use cases for those symbol layer types. And then finally, animated markers at 3.2.6, this was introduced. So this is some lightning points. Found an animated GIF for lightning, and the controls allow you to adjust the frame rate, the width and the height, so that you can get that animation to play at the speed you want it to. So with every version of QGIS, we also get a lot of expressions introduced. This is kind of becoming its own language. So at 3.2.4, expressions for geometry type, scale, wave. At 3.2.6, the operators between and not between were added. And at 3.2.8, a lot of variables that used to have the dollar feature, dollar ID, have now, there's been an attempt to make these more normal, where they all have the @ symbol in front of them. The dollar will still be recognized, but moving forward, it's recommended to use the @ versions of those. So here's an example of using that scale function. This is a cartogram where the features are being resized based on a data value. So here it's population density, so the municipalities here are being resized using the scale function, using geometry generator to create a nice visualization of that. And we have a whole series of wave functions. So this is, again, something you could use in concert with the geometry generator symbol layer type. So I have some lines across the coast, and I'm using the wave function, and it lets you enter values for the amplitude and wavelength. So I can adjust those values and change the way this line is wavy. And there's more. There's wave randomized. And there's triangular wave, square wave, and then the randomized version of each of those. So you can make any kind of wave that you want to at this point in QGIS. So moving on to labels. This is a subtle tweak, but it's nice. There's a new unit for label buffers, and it's percentage. So I can set the percentage of the font that I want the label buffer to be. And then if I resize my label font size, that stays proportional to my label size. So that's a really nice thing. If you're going to be resizing labels, you can use the percentage buffer distance for those halos. This one is a fantastic feature. At 326 came the ability, if you want to move a label that is a line label, you can now drag that label along the line and position it where on the line you want it to be. And it stays with the distance off the line that you've set, but you can drag it and reposition it. That's with the labeling toolbar. Moving on to print layouts. Now, with labels, you've always had full text rendering, but now when you add text to a print layout, you have the same tools that you have for labels, where you can enter a label buffer, an outline, a drop shadow, and do various text formatting. So here I'm just controlling the size of the halo, adding a drop shadow to my title, and then on this tab you can change the case type. You can choose title or uppercase or other options, and you can also control the letter and the word spacing. So it makes it much easier to create nice custom text on your print layouts. Moving into processing, the georeferencing tool has now been enhanced so you can not only georeference rasters but vector data. And importantly, this means that this tool has now moved to the layers menu. It's no longer in the raster menu. A lot of people are having trouble finding it, so it's now going to be on the layers menu because it applies to both data models. Here I'm going to add a DXF file that I want to georeference, and I can bring that DXF into the georeferencer and georeference it the same way I would a raster layer. And some of the more exciting changes have to do with the 3D environment and a new tool called elevation profiles. So you'll now in project properties see a terrain tab, and here you can set the terrain settings for your entire project. You can tell it which layer has the terrain for the project, and the 3D viewer will then honor that setting. With the 3D window, there's now a really nice feature that you can undock and dock that. So historically, this would be a panel that would dock, and if you're on a small laptop and you tried to move it around, it would get annoying because it would dock to different parts of the UI. Now you can undock it and have it be a free-floating window. There's also some nice tools for syncing the 2D and 3D map canvases. There's enhanced navigation panels, and there's also a 3D access, so you can visually see how the map is oriented. Camera navigation's behavior should feel a little more natural and similar to other 3D mapping software now. And there's also now a 3D views manager. So this is similar to the print manager, where you can save multiple 3D scenes in your QGIS project. So I can open up the 3D views manager. I can rename an existing 3D view. This is of Mount Rainier in the United States. So this is Mount Rainier 1. And then I can select that in the view manager and duplicate it. Call this Mount Rainier 2. And now I have two 3D views saved in my project. So when I close it and open it up, I can open up the 3D view that I want to work with. You'll also now find an elevation profile tool, which is fantastic. You'll, in layer properties, have an elevation tab where you can tell QGIS that this represents an elevation surface, this layer, and you can also control the symbology, how that will appear in the elevation profile. So once I've set that, I can click OK, and I'll open up the elevation panel by going to the View menu. So you'll see Elevation Profile, and it'll open up as a panel below the map. And you have a couple different choices here. You can capture a curve that you digitize, or you can capture a curve from an existing feature. So here I'm going to click on the route of this trail, and I get a profile that, of that hiking route to the top of the mountain. This works really well for point clouds as well. So here I'm going to use the other option where I digitize a line. This is a point cloud of Delft in the Netherlands that's styled with RGB values. So I'm going to capture a curve where I digitize this line on the map, and it will give me a sample of the points that that line intersects in the point cloud. But I can go into the tolerance settings and basically widen the swath of points that this will capture, and I get a fuller rendering of the point cloud across that line. I can also use a measure tool. There's a snapping button there, and then I can use measure distances to measure the heights of the trees, distances between buildings, and things like that. A lot of changes with point clouds. There's 2D rendering now respects Z ordering. Cloud optimized point cloud is now supported, and there's point cloud filtering. You're going to hear a lot more about this from Saber next. There's been improvements to the classified renderer, so now it only shows classes that you have on the map, and it will give you the percentage of each one of those so you can get the magnitude of each class. There's also, in the 3D viewer, when you have a point cloud, it's possible now to eliminate some of these gaps that you see by choosing render as a surface. And then it looks more like this, where it creates a more solid surface for your point cloud in the 3D view. Okay, so the last couple minutes here, I want to focus on new features in 3.3.0 and 3.3.2. Starting with Sertigan Bosch. You can now identify on a mouse over. So I can set the identify tool to identify features on mouse over. So now as I hover over this DEM of an old Viking ring fort, I can see the values live in the identify features window. That's quite nice. And one of the ones I'm most excited about is support for raster attribute tables at 3.3.0. So here I'm going to add a raster, a categorical raster, and it already had a raster attribute table associated with it, so QGIS automatically styles it according to the color table stored in that raster attribute table when I add it to QGIS. This is the attribute table itself, and you'll see the color table on the right-hand side. I can also change that classification. So here I'm going to right-click on a raster and open up its attribute table, and I'm going to change the field that is being used to classify this raster. Hit the classify button, and it will reclassify this raster according to this new column. Non-vegetated, vegetated. This raster attribute table is also supported by the identify features tool. So you can use identify features to click on the raster, and you see all the attribute columns and values like you would with a vector layer. And if you right-click on the layer and open up Properties, you'll have an Attribute Tables tab that previews that attribute table, and it also has tools for letting you edit that attribute table. Because that's another thing we can do is edit these attribute tables. I can put it into edit mode like I would with a vector layer and add a new column. I'm going to call this yes, no. I'm going to classify this raster into two categories. I can determine where this new field is added, click OK, and scroll to the right, and I see my new column. And what I'm going to do behind the scenes now is populate it with yes or no. And now I can use that new column to classify this raster based on values I've entered. So it's very nice. You can also create a new raster attribute table from a classification. So you can use the paletted unique values renderer, classify your raster, and then you can open up layer properties and create a raster attribute table if you don't already have one. In layer properties, you have the options to create a new attribute table from the current symbology. You can choose the format, and it creates it for you. Okay, the last version we're going to cover is 3.3.2 Lima that just came out this week. So one of the exciting things is that in QGIS, there is now a whole set of native point cloud algorithms in the toolbox. One of these that I think Saber will talk more about maybe is building virtual point cloud. So this is a new format of point cloud that QGIS supports. It's kind of similar to a virtual raster, but for point clouds. There's also a download vector tiles algorithm. So you can now bring in vector tiles and use this algorithm to create a local copy of those vector tiles. This will improve performance of large QGIS projects, loading layers and parallel threads when opening a project. So QGIS will now load supported layers in parallel, and this will improve loading times for those big projects. And the last thing I'm going to cover here is this fun new feature with profiles. So if you're like me, QGIS has always defaulted to the most recent profile that you closed with, but now there's a basic ability to manage those. You can choose the behavior on how QGIS chooses the profile that you're going to open QGIS with. You can set icons for each one of those. So I can set an icon for my default profile, for example, and icons for my other profiles. And if I have chosen here, let the user choose the profile at startup, when I start QGIS, I'm going to get this window here where I have all my profiles there with their icons, and I can choose which one I want to open when I open QGIS. So this is one of those where it seems like it should have been there a long time ago, but I'm glad somebody thought of it. So that's the frenzy, and I think there may be a few minutes for questions. This is my contact information.
Okay, yeah. 8 minutes for questions. So, do you have any questions? I do have a couple. Yeah.
When you georeference a vector file, what does it actually do? Does it just write a sort of transformation file, or does it project the data, and do you have different options for warping or transforming it?
I think it depends on the file format of the vector file that you're choosing. I think it produces a new one in the same, the default behavior is choosing the same format that it was in, but with a georeferenced sidecar file, or depending on if it's a shape file or what have you, it would create a PRJ. But just like with the raster, you have the ability to choose the output file name and the output file type when you georeference. So you can control that.
Somebody has a question? I do have one. I'm not very familiar with between and not between stuff. Is it attribute query or geometry query?
It would be a variable for choosing values between two extremes.
Okay, so it's not a geometry between two features that are maybe closed?
Oh, so now I may be rethinking that. I'm going to have to say that I may be wrong about that. I'm going to have to look it up. That's a good question.
Yeah, thank you.
Sometimes all these new features get lost in my brain too.
Yeah, that's a lot, actually. And so you speak about point line snapping?
Point cloud snapping.
Yeah, point cloud snapping.
In the elevation profile tool, there's a snapping button. And so when you have a point cloud in the elevation profile, you're snapping to actual points in the profile.
Yeah, but on the side of the line, I don't understand how it works.
Well, you have that swath where you see the buildings and the trees, and those are kind of modeled points from the point cloud where your line is intersecting the point cloud.
Yeah, exactly.
And so your cursor will snap to those points in the profile.
Yeah, but that's when you say snapping, it will grab the points maybe on the left or on the right within a certain buffer.
Yeah, there's a tolerance.
Oh, okay, it's in meters maybe.
Yeah, it might be in millimeters. I honestly don't know that. And there actually have been some changes to the elevation profile. It's been enhanced at 332, and so there are some new features that may be introduced there that I haven't looked at yet.
I will ask Saber.
Yeah, Saber can shed more light on all of this, I think.
Yeah. Oh, there is a question.
Thanks for the talk. The creating raster attributes tables, does it matter the raster format? Does it have to be a GeoTIFF or it could be something else?
I don't know how it would work, for example, with a GeoPackage raster. I expect it will work with every supported type of raster that QGIS works with. But then you probably have different options because one of the options is a sidecar DBF, but you can also have it embedded in the format. And so that depends probably what the format is, if it supports that or not.
Thank you. Any more questions? Thank you very much, Kurt.
Thank you.
Please applaud him to say thank you. To change speaker and if you need to change room.
Test.
Okay, so next speaker will be Saber Ramzoui. Well, he will be speaking of QGIS 3D, point cloud, and elevation data. Thank you, Saber.
Hello and good morning, everyone. Welcome to this presentation. In the next half an hour, I'll walk you through some of the features in QGIS 3D. The exciting bits already Kurt has covered, but I try to add some more context. I'm Saber from Lutra Consulting. We are one of the core developers of QGIS in the past 12 years. And some of the features you work with, we have developed. So if it works well, it's us. If it's crashing and gives you problems, it's also us. Blame us. We also have a mobile app, which my colleague will talk after that, based on QGIS. Okay, the first part, point clouds. Since in 2022, we started a crowdfunding campaign to include point clouds or LiDAR data inside QGIS. We teamed up with 2 other open source companies, North Road and Hobu, to do this task. The main problem was really finding the right time zone in Europe, North America, and Australia to have a meeting to talk, but eventually we got there. The initiative, the whole idea behind that crowdfunding was based on feedbacks we had from the community. This LiDAR data was lacking in QGIS. There were some third parties and some tools that did conversions, but there was no native tool in QGIS. Also, there were some open source tools to open LiDAR data, but on the other hand, you couldn't overlay it with the rest of your GIS data like vector, raster, web services. So we thought it would be good that QGIS, which is a very generic desktop application, to have this feature. We prepared a proposal and put it to the community, and they generously funded our work. The first one was to integrate the visualization, the PDAL library. It was in 2020, and we successfully raised enough fund to do that. Then again, we had lots of feedback from community to add more tools like elevation tools and some more visual effect when they load data. And we had another crowdfunding, 81,000 euro, and that one was successful as well. Then the last one, which I'll focus on, it's the introduction of point clouds processing framework in QGIS, which was done late last year, October, November, and now, as of the new release of QGIS 3.32, it should be available. Oops. I broke the whole thing. Oops. What did I do? Last tab. Okay. Point cloud data are okay. Good. Yeah, that's the one. These are some examples of point cloud data. In this case, you will see over 1 billion points covering a large area and with different categories, classifications. And then another example is the mobile scanning data. This is from Vienna. And last example, it's, for God's sake, yeah, okay. It's large point cloud covering Sydney, I think. These are all visualized in QGIS. And to get there, things we had to overcome. was handling large amount of data. The common file format for point cloud is LAS. These are very good for storing data, but they are not optimized for visualization and processing. So we did in the behind the scenes some indexing. When you load the data for the first time, it does some indexing and creates some files. Then it reads those more efficiently, and you can visualize large areas. Point clouds have got lots of data behind it. In this example, you have classifications, different land use. You can easily in QGIS load the data and show those classifications. Another type of data, it's the Z. You can have the symbology, the renderer set based on your elevation data. So you can create some impression of your digital elevation model. And then some of them have got RGB, and you can see it similar to aerial photography. Also, in addition to 2D, you should be able to visualize that all in 3D as well. Then to improve the visualization, you have also the dome lighting, so you can easily identify the features. This is without, and the other side is with. You can see easily how what features you have. Another one, both eye doming works in 2D and 3D. Then ambient occlusion. You can easily identify trees, for example, by having this feature. Then ordering of your points. In this example, if you look at this part, for example, you can't, the black dots now reordered, and you will see proper roof of your building, and the order changed from bottom to top. The other improvement, as Kurt mentioned, we have now classifications plus the percentage of the points, so you can see for each class what percentage of points you have. Also, you can see the non-standard classes here as well. Filtering, if you have a large point cloud and you want to see a specific filter, a specific class, similar to vector data in QGIS, you can apply a filter and do it based on classes or based on elevations, etc. You can easily filter those, and once you apply it, your map will just show the result of the filter. Another useful tool is to have this 2D renderer to follow your 3D. When you set the scene in 2D, it used to be the fact that when you go to 3D, you have to apply all the settings to the 3D, but by having this, they both show the same thing in different map. Another one, showing the point clouds as surface, that's it fills the holes. Also, one of the challenges were the size of the triangles. If you have very steep triangles, you can filter those, and it skips the triangulations for those odd ones. Export to file. Everybody loves shapefile, so why not exporting point cloud to shapefile? And with this feature, you can both export and filter the data on the fly, and also set the attributes you want to export. And there are some tools that unfortunately don't support point cloud directly, and the clients want the point cloud in DXF, or shapefile. This is a way to convert them. And then cloud optimized point cloud. As I mentioned, LAS files are good for storage of data, but they are not very optimized for displaying and processing large data sets. So there is a standard COP-C, and similar to GeoTIFF, when you create a cloud optimized, it creates an indexed, and you can easily either stream the data over a URL, or you can just have it locally. Then it will be much easier for your client to visualize or process the data. And we were one of the first software applications, QGIS 3.26, to opt for this format. This is an example of using it as a file, or you can just point it to your EPT or COP-C. And if you are a data provider, you want to cover a large area by streaming the data to your user's desktop. They don't need to download gigabyte of data to find what area they need. And also, it will be fast to process from the client side as well. So this is an example of a LiDAR data. This is EPT, the predecessor to COP-C, and it's easily visible can be visualized in QGIS. Point cloud processing. We base the processing on PDAL. PDAL is similar to GDAL library, but for point cloud, it handles read and write of data. Also, it has some processing tools, but it's slightly different to GDAL. Instead of having standalone processing, you have filters, and it has got a Lego approach. So you need to create pipelines by putting those filters together, and to create a pipeline, for example, to create a DTM out of your point cloud. It gives you ultimate flexibility, but to integrate it into QGIS as a desktop user, they don't want to handle this kind of scripting. Also, the parallelization is done by user within the scripting, but for desktop user, again, it will be a hurdle. What we did, we wrapped up all those functionality in a new tool called PDAL Wrench, and it does create a script, for example, in this case, to convert your point cloud to a boundary. And you can run it either from terminal, your shell, or it's integrated within QGIS as a processing tool, and you can run it from there. It also automatically handles the multi-processing, the parallelization based on the number of CPUs you have, so you don't need to do any manual work on that side. And by doing that, we have got this list of processing tools in QGIS in 3.32. It's the starting point. It might not look very comprehensive, but it's the building block that you can in future add more and more filters and pipelines from PDAL, so that the framework is there. I give you examples of some of them. This is the clip by polygon. So you create you have got a point cloud input layer and a polygon, and run it, and it produces the clipped version. Density, you can create a density of your point cloud where you have got high number of points and low numbers, and then filtering by expressions, so you can filter the input data based on expressions similar to the one I mentioned earlier. And this one creates boundaries. So for example, you can create boundaries of your buildings, trees. And then the popular one is to export it to raster. So you can create elevation models out of your point cloud data. Yeah, and there are some others like thinning. So if you have a very large coverage of the point cloud and you want to have a resampled version to give an overview, you can create a thin version of that. You can export that as a vector layer. You can merge data and also tile data. So if you have a large coverage, again, you want to have them in 100 meter by 100 meter or kilometer by kilometer, you can do that. Fixed projection, conversion, they are self-explanatory. And the more exciting one is virtual point clouds. It's when you have lots of large data similar to GDAL virtual raster, we have adopted virtual point cloud where you reference several LAS files, and then the format of it is based on Stack API, so each of those will become an item collections. You can, if you have a Stack compliant software, you should be able to do it similar to the one to COP-C viewer. And it can reference local files and remote files. Then you can load it in QGIS, visualize all the coverage of your point cloud. As you zoom in, the point clouds will appear. Also, the beauty of this is you can do all sorts of processing I mentioned beforehand. Let's say you want to clip the data or create DTM of large data. You can easily load the virtual point cloud for a country and then just select an area and clip the data or create DTM in a specific area. So this the visualization is also available in 3D. This example with 37 billion, and it's smooth because the data is streamed and you can easily see the data. Okay, I'm running out of time, so I quickly go through the 3D improvement. Kurt has mentioned most of them, but one that it's available now, it's measurements in 3.32 or global. Okay, this one is 3D measurement, so you can smartly move around and measure buildings in 3D scenes. It nicely snaps in on your objects, and you have measurements in X, Y, and also Z. And I give you a preview of some of the upcoming features. Confirmed works in QGIS 3.36. We will introduce point size renderer, so you will be able to change the size of point cloud based on some attributes. You can also see the point clouds as a surface in 2D maps. In QGIS 3.34 later this year, we will have support for 3D tiles that's funded by Cesium. So you can create those nice Google Earth type of things inside QGIS. And also, if you want to bring across some of those interesting PDAL pipelines for filtering and noise reduction, classification, the framework is there, and we should be able to introduce that easily. So come and talk to us. Okay. I think it's the last one. Yeah. Any questions? Yeah.
Thanks for all these cool features. I'm not sure if I should address this question to you or to the PDAL team, but have you any plans of integrating like GPU-based parallelization within the processing of the point clouds?
Not at the moment, but yeah, it's mostly to PDAL. We can ask our friends there and see if they have any plans.
Thanks.
it will be an interesting one, yeah.
Thanks.
More questions? I do have a couple. So most of the features you present today were crowdfunded.
All of them,
All of them.
yes.
So, as an individual, do you think it's a good way to finance open source software?
It is, because the budgets we needed were mostly beyond most of the organizations for procurement purposes, and also individuals. And I can see lots of faces who have funded our work, so thank you very much. So it was a good effort, community effort, to put this proposal to the community. This is what you need, and basically you give us money and we will fix your problem. And it worked well. But the key part was to listen to their feedback, collect some generic proposal to make sure that it addresses their needs, and then go back to them for funding.
So it's a dialogue between founders and developers.
And community.
Yeah.
Yeah.
Great. Any questions? Yeah.
Okay. So, how much data or point cloud do you think can load it to QGIS? I mean, I put my 20 gigabytes of point cloud data to QGIS, but it didn't work well. It's heavy to change the point of view, so I'm not sure how much. Yeah, I can load it. Yeah, I know it depends on the RAM size or CPU, GPU size, but I have 128 gigabytes of RAM, and then GPU and CPU is also the best one.
Yeah.
But it didn't work. So how much do you think data?
The key part is to create, when you load the data, to create this indexed file, for in this case COPC. If you have COPC, the one I showed you earlier, it had 37 billion, so it should be able to stream the data. It knows what at zoom level you are, and the files are indexed, so it should be able to handle it. Feel free to come and we have a stand, talk to me, and there are ways of creating indexes within QGIS to streamline the visualization.
Okay, yeah, thank you.
You're welcome.
Questions? Let me check. Let me check the time. I think we have time for. Yeah, I have a question, and we have time. What is Stack API?
Stack API is spatial temporal asset catalog. Yeah, am I right? Yeah, it's the API for creating cloud optimized formats we have lots of presentations, so best to attend the presentations of
Okay,
other colleagues.
it's for cloud optimization stuff.
Correct, yeah.
Thank you. And you saw when you create a virtual point cloud,
Yeah.
you have a coverage, and it's generated automatically.
The coverage is generated automatically. You also have an option to create a thin version of your point cloud for the whole coverage. So if you select that option, you can create a very light file for higher zoom level, so you can see all the province, region in a very coarse to get an appreciation, and then you can set the zoom visibility as you zoom in, turns off the overview and zooms into the detailed tile.
Okay, so it's an aggregation of points, or it's a sampling of points?
It's not the thin one, or is it?
The coarse one, when you are very large.
Yeah, the coarse one is aggregation of everything.
Okay.
So
Thank you.
you're welcome.
Thank you very much, Saber. We
Thanks.
have 5
Thank you.
minutes. We have 5 minutes to change, and I'm looking for Thomas. Yeah, it's you.
Test. Ook al niet. Ook niet, ja, dat is als ik al aan niks. Test, test. Autobahn. Test, test. I. Aber nie in Haar, ja, just. Sen dolsem komut milit kontra. Prednji minut. Test, test. Autobahn saš? Test.
Yeah, please welcome Tomasz Mizera. We'll be speaking of 1 year of progress in merging math. The floor is yours.
Hello, hello. Great. Hello, everyone. It's good to see you there. This feels like being a rock star. Cool. So let's rock with merging maps. So this is a presentation about the last year in merging maps. Let me quickly introduce myself. It works. So my name is Tomasz. I work for a company called Lutra Consulting, as my colleague Saber in the last talk. And I work on a project called Merging Maps. I work as a PM in the last 3 years, and I'm based in Slovakia. My background is in computer science. Let's do a quick poll in the beginning. Can you raise your hand if you have ever heard of merging maps? Cool. Almost everyone. And if you have used or are using actively merging maps? Great. Okay, thank you very much. So let me quickly go through what merging maps is. Merging maps is a field data collection tool, or one could say ecosystem. So we say it's a mobile app or a tablet application for you to use outside in a field to collect their spatial data, but it actually does way more. We store and track changes thanks to our versioning. Everything okay? Okay. Thanks to our versioning system. Merging Maps is tightly coupled with QGIS, and it works hand in hand with QGIS. It works also offline if you prepare your project like that, if you have background maps downloaded in the phone. And if you have a mobile phone coverage, you can easily synchronize your changes from the field with one click of a button in the mobile app. With the QGIS compatibility, as I said, we are running QGIS under the hood on the mobile device. So how it works is that you prepare your QGIS project and all your background maps, vector layers, forms, and styling look the same on your mobile phone, just as they look in the QGIS. Merging Maps takes all the forms from QGIS and parses them in the app. With Merging Maps, we strive for simplicity, so we try to keep Merging Maps user interface as easy as possible, and so that you don't need to be GIS expert to use Merging Maps. Oh, sorry. As I mentioned, you can customize your forms in QGIS, so you are the boss of the forms. And we are open source project. Sorry. Can we have a minute of pause? Yeah, sure.
Okay, I will try to take for a minute. You can host your project, so your data could go to cloud, to our SaaS service, or you can self-host it on your servers. So it's either Community Edition, which is on GitHub completely free, or Enterprise Edition with a bit more features. So a year of progress. So big things happened in last year. We become self-sustainable, which means that from our cloud we can run our servers and all our team, which is quite large now, like 12 people working on the project. So buzz factor is quite high. And we have this new community edition, which you can host on your servers if you like. It's completely open sourced. So this is one very big feature that is coming in the next release. It's already on a store's beta program. So if you have a beta program, you can download it. And it's background tracking. So actually, when you want to track when your team is out and you want to see a track where they are, where they've been, and what they did. So the app can run in the background and store the path as a layer. So then you can analyze it and get the path. It collects position and time, and it's very good for planning of the visits or analysis and managing the crew outside. Yeah, this one will go out just right after our testing. So now it is in our testing team, and if it goes well, probably you will have it in your production release on app stores and Google Play in a few weeks. So, what is? So Tomáš is ready. So let's get back.
Thank you, Peter. So I probably won't be a rock star in the end. Right. So as Peter mentioned, the tracking, it is not going to be enabled by default to keep the user interface simple, but you will need to go to the QGIS project to set it up. So if you go to QGIS project properties, then margin maps, you will find a new box called tracking here. And you will be able to set up how often you want to see position updates. For each position update, can I go back here? Yeah. So for each point in the line, this is, by the way, my way to get a kebab the other day from here. So for each point, we collect X, Y, Z, and M. So, and in M, we store a time dimension. So you can see at what point where you were. This is very useful for managing your crew or as a proof of a visit. Companies like Natural Resources Exploration will be using that for making sure that the crew went through all the places and explored all the like area they wanted. And it has like wide variety of use cases. Last autumn, we added a feature called geometry editing. With geometry editing, you are able to update geometries of new and existing features. You can update points by moving them, or you can add new points or remove points. On this picture, you can see that you can update the geometry of polygons, lines. You can also update geometries of points and also the multi-variants of the geometries. I have a GIF here. So you open a feature, you click Edit Geometry, you click either on an existing point or some new point in the middle of a line. It's very similar to how QGIS works with editing geometries. And you can also remove or point or undo all of your changes. Margin Maps is capable of connecting external GNSS receivers to achieve like a higher accuracy. And for that, it's often the GNSS receiver is often attached to a pole. And you might want to you might not want to record the position of elevation on the pole, but on the ground. So that's why we added this GPS antenna height settings. So what it does is that when you set it up, it will automatically subtract the height of a pole from the elevation that you captured, and you can see it here in the user interface. We also adjusted our streaming mode. So streaming mode is an option for you to capture geometry of any area. You can start it and go around, let's say, a property to capture geometry of the property. And previously, we had an option to have a time-based. So each few seconds, you added a new point to a geometry. And now we added also a distance-based threshold. So you can do it each few meters. I'm sorry, I'm not sure what is happening.
Okay, hope this is fine. Layer 3, it's similar to QGIS, Tomasz mentioned. So always preferable way, what you say, is these map teams. And actually, it's not that easy to set up in QGIS, as we found out, because that's the most frequent page on our documentation, how to set up map teams in QGIS. But map teams are cool for your surveyors, but if you need more granular access, like switching one layer off or on or see legend directly in a field, and you don't have it set up as a map teams for your surveyors, you can do it in this dialog. So yeah, now there is also a new feature in the beta that in this dialog, in layers, you will also see the attribution. So if your layer has set up attribution in QGIS metadata, you can see the attributions here. Okay, the workspaces, actually it was a huge restructuring of all internals on a server, and but it's a lot of background work that is not visible for end users. But for you, it's one big positive with this is that when you set up a new workspace, so you want to get on board one of your clients, or you are registering a new project on a Merging Map server, it's very easy now to invite all your colleagues. So you register the workspace yourself, and then by emails, you just invite your colleagues. They get invitation, and with 1 or 2 clicks, they can be in a workspace. So now it is very easy to set up your team for your clients or your company. And it's all integrated in mobile and QGIS, the plugin. And even if you have more clients, so for example, you are a GIS consultant and you work for 5 clients, each client has its own workspace and their project, you can now select in plugin or server or mobile the workspace for your client, and you see only the project of the client. So they are not mixed up. So it's very more easy to go with multiple clients or multiple groups in one company. DB Sync, it's a feature of PostGIS where you can replicate one geo package to PostGIS. So all merging maps is based on geo packages as survey layers. And with DB Sync, you can run it as a daemon, either here in a Docker, or here we have also Windows installer. And it can synchronize between merging maps and PostGIS, for example, each minute. And if you do any change in PostGIS or merging maps project, it will go both ways. So this way, you can have your data in PostGIS for everything else in your infrastructure, but still use merging maps for field surveys. We did a lot of robustness and logging fixes. There is also a YouTube channel of merging maps where you can go and see the quick tutorial how to set it up. We are working on a wizard in a plugin where you will be able to take a QGIS setting of your PostGIS and automatically generate all the settings for this tool. So it's easy to generate the setting tool and run it. Yes, so this is our team of our team meet in Brno. We work completely remote, but we meet a few times per year, some are in person. As I said, we have 12 colleagues working on the merging maps, and we have thousands of active users from all over the world. And in last year, we did 2,000 commits. And the project is open, so we have some old contributions from the community too. We did 25 releases of plugins, servers, application, and so on. And we closed 180 GitHub or issues in total. One of the very big change we did also, infrastructure change, is migrated to Qt6 because of the support for newer Android versions. But it was very painful. We found a lot of Qt bugs, and still we have some very obscure workarounds there. But Qt team is quite nice, and now with this new Qt 6.5.2 version, they try to fix them. So hopefully, the Qt will be usable for both merging maps and also QGIS, which is a plan to migrate to Qt 6, and is very much ongoing. But this was a big change, but nowadays it's done, so we can move more quickly. For the roadmap and next goals, tracking, we talked about the tracking on the first slide. This is a background tracking when you can track the path of your crew. We want to also create a very easy way how to publish a map. So when you done your survey and you want to present the results to city council or the company, then you can one click you can generate the map that can be shown to others as a public map. This is a plan for next month, one of the big ones. And we want to improve onboarding a bit, so we'll run some easy background maps for these wizards we have in an application. Also, we will work on a new brand identity and cleaning up the user interface. This is a recent change of last week. Bake it for FOSS4G. We subscribed to one SaaS product, and we have running a wish list nowadays. So if you have any requests or wishes, it's not best to go to GitHub and run and create the enhancement tickets there. But it's better to go here, find out if such issue is not here, comment it out, and most importantly, vote up. Because we will very likely use this as guidelines for next development. So we will try to pick the issues that people would love to see in an ecosystem and pick from them. Of course, we are going through the GitHub for bug fixes and also for enhancements and try to migrate them here, but this would be the primary place for new features. So, to sum it up, we reached a sustainable state last year, so the project is going very well, and we try to grow in terms of users and both team. There is a position tracking that you can try in the beta or wait a few weeks. We have the new community edition, which you can use completely for self-hosted open source solution. And we have the wish list. We have a lot of many features. And we'll try to publish the online maps, simple online maps. If you want to hear more, there is a case study right after this talk in academic track about actually the local use of merging maps. And there will be my talk tomorrow about not about the features, but more about the ecosystem and more basics and how we approach generally support or partners or other stuff in the ecosystem. Oh, there is a chess figure. So if you want to win a free year subscription individual, feel free to beat me in a chess and you get it for 1 year free. Okay. Oh, that's one. Tim is not here, unfortunately, so no one tries to play with me. Okay. Okay, I think this is the last slide. So thank you very much. I'm not sure what's the time. Yeah, it's fine. Yeah. Tomasz is fine, so everything goes right.
Thank you.
Any questions? Yeah.
Thank you, Tomasz. Thank you, Peter. We have 4 minutes for questions and changing. So, any question in the crowd? I do have one, maybe. So you mentioned it's compatible with QGIS, but is it compatible with Grass or Saga or with other softwares?
It is kind of QGIS running on a mobile, so like it is compatible in a way that if the other software can use Postgres or can export and work with geo packages, then it is compatible. It's yeah.
If we want to access the data outside QGIS or the application?
Yes, so there is a Python and C++ API client, or there is REST API if you want to use a web technology. So you can leverage this Python or C++ or REST API and do very fancy advanced workflow with that if you want. So it should be possible to connect to like whatever you use.
Okay, thank you. Any other questions? Thank you, Thomas. Thank you, Peter. Next speaker will be Matthias Kuhn in 4 minutes. We have time.
maybe. Probably. I think I take it. Test, test. I can use that one to skip the slides, probably. Going back is harder. Yeah. Okay, I just don't go back. Okay, there is no way back. Well, there's too much to tell as always.
Now you have 20 minutes. I will give you a 5-minute notice.
How do you?
I have a
You have
paper or my hand. 1-minute notice.
Yeah.
But if you
Go over time.
go over time a little bit, it's okay. I won't serious. I won't get on the stage and
Well, that would be fun.
yeah, but what we need.
Ok. Tu fais une introduction?
C'est vrai qu'on peut se parler en français.
C'est chiant. Pas de souci.
Yeah, for this last session, please welcome Matthias Kuhn from OpenGIS. He will be speaking of news of QField. Please, Matthias, floor is yours.
Thank you very much. Welcome to this session about QField. It's meanwhile a quite standard session that I'm giving very often, and it's always a bit hard to like cover the discrepancy between like showing some very basic concepts and the latest and greatest features that you want to show to people anyway, which are very natural to me now and very current, very actual. So basically, QField, professional fieldwork. I'll just give you a super short introduction. Open source GeoNinjas made in Switzerland. We are OpenGIS.ch. We do a broad range of services around development with a couple of QGIS core developers, including me. I've been developing QGIS myself for roughly 10 years, a bit over 10 years actually. Been quite active in there, nowadays a bit less than I used to. And yeah, that's, and I also started QField myself back in the days. I'll maybe get back to that later. QField for QGIS, I guess most of the people in here have heard about it before. It's an award-winning app. We were super proud last year to have the Best of Swiss Apps Award in the category Enterprise. So that was quite amazing. And actually we were a finalist in the category User Experience, which was quite interesting for me, because quite often when you develop apps, you have specific use cases, and that's where you bring in all the user experience and all the UX team. Whereas QField is like an all-around Swiss Army knife tool, and it's apparently still able to do some UX, and that made me proud that we were able to defend all the requests for too many buttons and keep the user interface as slim as possible. So why did we actually start with QField? Because basically data is outside the office. You might have aerial imagery and whatever in there, but sometimes you just need to go out and you need to collect data outside. What is it? So it's a mobile data collection app for QGIS, and it is actually based on QGIS. We will hear more about that later on. It has a super minimalist UI. That's what I said before, like with the few buttons. We try to really only show buttons when they're really needed. So that means like if it's possible to somehow spare away a button and not even add it, that's even better because, well, some buttons you don't just need them. And on the other hand, some buttons, like there are a lot of powerful tools inside QField as well, you will just show them when they're needed, in the context when they're needed. And yeah, that's the basic map view here that you see. There's just a few buttons that are always visible in this case. There's beautiful cartography inside, which is not actually QField's fault, but QGIS' fault. And it's great that QGIS just delivers still, and even every year, a bit better cartographic possibilities. And I've seen some amazing maps being produced. We have powerful tools inside QField. So even though the interface tends to be quite small when or minimalist when you started, you have things like cutting features, duplicating features, merging features. So there's plenty of like advanced possibilities to edit polygons, to do geometric operations on things. Yeah, there is, and like topological editing is a button, so you can try even to get already quite good topology on the field. I wouldn't completely rely on that, better do your checks afterwards in post-processing, but anyway, like you can already have a quite good data quality for topological data by using topology. There is a lot of like efficient interactions. Set feature as destination is here, for example. We'll get back to that later and skip that slide for now because there are plenty to come still. Then a lot of like beneficial integrations, like taking pictures for your features, attachments for your features. And one of the things that we've been very, very active on in the last year is professional hardware integration, like this one. I'll also get back to that later on, like specific GNSS devices, but also other hardware, how we can deal with that. Just a short recap. It all started back in 2010, actually, when my colleague Marco Bernasocchi started with a Google Summer of Code with QGIS for Android. I think he spoke about this in the opening keynote, had fun compiling all the libraries that are used for QGIS for Android. And then a couple of years went by, and we had like QGIS on Android devices, but still with all that like toolbars and tiny little buttons you don't really want to use with a finger. And so basically between 2013 and 2014, we had the first commit on the QField repository, which eventually went into QField 1.0, which was released mid-2018. Then, like roughly 4 years later, we had QField 2.0, and now we are somewhere in 2023, just after the QField Cloud release. I'll just zoom in a bit on that map, because quite interesting for us is that between the release of QField 2.0 and I think 2.8 is actually missing, that should also be there, and nowadays, that was amazing, like the speed of development that happened around QField, the number of features that went into it, it just like really got a lot of traction recently, and it's, yeah, there's a lot of stuff that has been coming in recently. Supported platforms, recently, more or less recently, QField on Windows is available, which is, I think, quite handy on the one thing when you configure a project, so you can quickly test it just without like putting your project onto a mobile device. You can just directly test it on Windows. It's also available for Mac and for Linux, in case you happen to have one of these like I do. And finally, next to Android, which we support forever, it's also available on iOS. Something new is that we support tracking on point layers, so tracking of lines, so that's like walking around and just continuously tracking your position has been available for a while, but now we also do tracking on point layers, and that gives some amazing functionality, which I will be able to demonstrate later on with a video. So there is also a pretty good integration for external GNSS devices, which you can see here. Like there's, you can attach an external Bluetooth device and then get access to all the high precision information from Bluetooth devices. And actually, it's not only Bluetooth, which we've had for quite a while already, but nowadays it's also possible to have like UDP and TCP integration. And that is quite cool because then some manufacturers, some hardware device suppliers, they can provide like their corrected data, because with Bluetooth, maybe I need to start there, with Bluetooth there's always like the problem that you have like, you need to get corrected, RTK corrected or NTRIP corrected data already through Bluetooth. And that like on the hardware side, you need 2 Bluetooth channels, and that's quite hard. Only some hardware can do that. And so with like UDP, it's now possible that the manufacturer of a hardware creates an app that uses one single Bluetooth channel, which like many devices have, and then just forwards the corrected information to Q field. Long story short, this just gives better integration for a lot of external antennas. And it also allowed us to do some proper unit testing so that we can actually like be sure that we cover a range of scenarios with NMEA parsing that we were not really able to properly control before that, because in our integration test environment we don't have Bluetooth devices lying around, but UDP is quite easy to do. One more thing that might be very helpful if you're doing like a professional surveying is positioning averaging. So that's something that we've added a couple of releases ago, which is quite new. And you can basically get a couple of points and then collect like 10 or 20 points. And within these points, you create the average, which gives you a much better more precise position than you would be normally getting by just collecting one single point. Back to professional hardware in general and NMEA integration. So there is this one device which we happen to have at our booth, maybe you've seen it before, which has an IMU integrated. So that's an inertial measurement unit, if I'm not wrong. And that means that it knows like the direction it is looking at. And with that pole of 2 meters, it actually knows if I hold it like this and it's 2 meters at the 30 degrees angle up there, it's actually measuring the point at the end of the pole, which is quite cool if you have to measure something which is like covered by a roof where you would normally not be getting a super precise position. But with that, you can just go and hold it a bit steep and get the position. And it's also not like super critical that you hold it like precisely with the bubble to get a good position. There is a possibility to do navigation and stakeout. This is something that we wanted to do for a while and finally have had the possibility to do. And basically with that you can do navigation. If we talk about navigation in this case here, we don't talk about like turn-by-turn navigation as you know from Google Maps, but more like, okay, you need to go somewhere and dig a hole and you just need to go like, I don't know, 50 meters in this direction and it's exactly there. And it gives you like your orientation, your distance to the target, and allows you, for example, also if you have a polygon to go, if you have a test field for your some project, scientific project where you want to check the same area multiple times, you can go there and find out the borders of that area. And next to like the rough direction where that brings you pretty close to it, there is also this what we call the precise view, which as soon as you get within a really short range of the target, you will see a blue dot appear and a circle around it. And as you move your pole or your antenna, you can really get it really close to the center until you actually have exactly the point that you need. And that's pretty cool to get like the precise like centimeter. For example, the GNSS antenna that I showed before has like sub-centimeter precision, so you can really exactly go to where you need to be in the end and get some sound and haptic feedback if you're there for extra fun. And this is actually one of my favorite integrations, which is external sensors. Happened to be this spring. And what we are seeing here is a tracking where we track points, actually. And this is somewhere, and someone is running around with something, I think in English, it's probably also called Geiger counter, like where you have you measure the radioactivity. These are people doing some cleanup of sites, possibly polluted sites by nuclear radiation. And they need to know where the radiation is highest. So they have an external device connected via serial port to QField, and in real time, all the points that they're collecting, getting like the value of that current point, which means they also get like on the field directly, they will see like where the hotspot is, on where the highest value is. And you see that like things start a bit to blink and go on and off. And this is basically because it takes into account all the other points on the field. So we are not like having a fixed threshold above which it will be yellow, but it's rather yellow or red based on like here's the highest radiation on this side. And they had another view where they had fixed values, and with the two of them, they could really get a they were like saying like, okay, normally we would be doing that and then going back to the office and do a lot of post-processing, then realizing that we missed some things, and then we had to go back to the site and do it once again. And there was like an immense boost for them. And shortly after, we had some other people telling us that they connected their own serial ports devices to QField, and I'd love it. And something else. It's a beautiful example of how we always strive to also make QGIS better, because basically the implementation that we did here, we did directly in QGIS. QField uses QGIS under the hood, so we can also use it from QField. But if you have QGIS and you prefer, instead of running around with your cell phone or your tablet, you want to run around with your computer, you can do the very same thing with QGIS. Working with attributes, let me check the time. Maybe I don't do too much there. There is a QR code reader, there is a bit of an outlook, there is an NFC reader coming up shortly. There is the possibility to work with temporal properties, so you can do like temporal filters on your layer and only show some features that were created or did by time. We had some archaeological people doing that to show where and what, and this is just some example here that we made up of hiking routes. Atlas printing is something that's possible. That means that you can create in QGIS your atlases, and then right on the field, you can directly create some printouts. Either you create that as a PDF export, which you can then send by email to someone, which is something that people do. And even more, there are also mobile printers, so you can just take a mobile printer along and directly print some things. I think I need to tell that example because I find it just really, really nice application. It's about cadastre and property. So in a lot of like the global south and developing countries, we have this problem that people, like they live somewhere, but they don't actually have a proof of their property, right? So there's more and more initiatives going on where you go there and then you like ask people, where do you live? You get like 10 neighbors to sign who is living where and kind of have that as a proof, because like having all the juridical background work would be way too expensive and too much work. So you just do that, and that acts for people to protect their own goods over like multinational companies that otherwise could just come and say like, hey, look, we have that paper. And yeah, so that was used for this kind of thing, like directly mapping it on site, printing it, and then having people sign their neighbors' parcels. You can do a height profile, which is some nice, we were just benefiting here from what QGIS itself did. Should be coming up soon. So basically we measure the length of something and then we say we want to do the height profile, and then you know if you really want to cycle up there or not. One of my favorites, we finally have a dark mode. Multimedia. another good example of developing in tandem with QGIS. So basically, this one here is a new development we did for not only photo integration, but also video and audio nodes. So here we did a video of some Omani men doing their dance, and geolocalized it, added it to a point, sent it through QField Cloud, and I'll just fast forward to QGIS, where we downloaded it again and had a look at that point, and the very same video clip. You can now look at it in QGIS. So that is available since QGIS 3.30, I think, that you can also add videos thanks to QField. In the end, it's now possible to handle multimedia scenarios in QGIS. You can rotate your map canvas either by 2 fingers or also by your magnetometer. Some prefer to call it a compass. I need to go faster, so. And something is like, you might have heard that there is like a QField Cloud which you can use to share data, but for us it's always important that we don't lock users into our systems or services, even if we really love that people use it. But actually it's also possible to just export and import, like if you receive something by mail, by some text message, you can just open up a georeference PDF, for example, that you receive from somewhere in QField, and also share it with someone. So that's possible. You can search for attributes and coordinates. There's a measurement tool, which I won't go into detail, and there is so much more for like geometry editing and drawing, GNSS and tracking, dashboard widgets like QML and HTML, which gives you like visual feedback. I think on the first slide I had some example of some bars. QField Cloud, I quickly mentioned it. I won't go into detail with that. My colleague Marco will be giving a talk about that at the same stage here at 2:30 this afternoon. If you want to join that, it's for synchronizing your data from the mobile phone or tablet with the office. And yeah, basically it's free and open source. That's where you can get it. And there is 750K Android downloads, 65K iOS installations. We don't know how many Windows installations there are because we don't have the statistics. A lovely 4.8 star reviews with 5,700 reviews. Please help us to make that even better. We'd love that. And 250,000 monthly users, whatever. And the UN suggested QField as a data collection tool for their UN things. Now, finally, I know the time is up, but I need to do that pitch. I'm sorry. We are going to launch a crowdfunding for QField these days. It's about background tracking. We are able to track our position when we walk around, but there is one limitation at the moment, that you need to keep your app open all the time. That drains your battery if you like switch the app. So as soon as the app goes to the background, you will no longer have the possibility to continue tracking because Android will just kill it. So with that development, we have a proper background process to do that. If this is something that you'd like to see happen in QField, or if you'd like to support us in general, there's the URL, or check it out at our booth. I think it's a great enhancement to QField that we would love to do. Yeah, so your time's up. Thank you very much. And questions?
Thank you, Matthias. We have time for a few questions. Don't be shy. Yeah.
Thank you for a nice talk. I work a bit with sensor data, and especially the way that you can collect data from UDP is it's something that I'm used to work with those data. But it can be a lot of data coming into the UDP. So both for the, do you have some filtering possibility? Because how do you filter out the data you would actually record?
In You're talking here about positioning data, NMEA, or about sensor data in terms of like the Geiger-Zeller example that I had? Second one. Okay, so basically what is happening in the background, we just stream in the information, but we don't necessarily record a point for every new record that we get. And what happens is that you set up your tracking mode and you set a time or a distance interval at which you want to take points, and you will just take the measurement at that point in time when your point is added. So basically by controlling your point collection frequency, you control the interval of the data measurements as well.
Okay, thank you.
More questions? Yeah.
Thank you. Hello, carrying on with that question, are you saying that it performs dynamic segmentation along the path with the time interval of the sensor?
Sorry, I did not completely understand the question.
If you have a higher frequency of sensor responses, is it snapped to an adjacent position reporting, or is there a path defined with a M field that the positions are interpolated from the time stamp on the sensor?
So basically the sensors that we attached here, they did not themselves send either a position or a specific time. They really just continuously stream the value as they're measured. So whenever you take a point, it will take the last measured value and does not do any interpolation or anything sophisticated to attach that or snap that to a location.
Thank you, I understand.
Other questions? Okay, I have one. Do you know about the Centipede RTK project, which is an open source project to make very precise location?
You want to tell me about it?
No. Actually, it's a French one, so it's basically GPS antennas that display their position by internet, and so you can get corrections, real-time corrections.
Ah, okay. So, yeah.
And it's open source. It's very active in France, but also worldwide. And I would like to know if you have integration with this project, but obviously not.
No, not so far, not so far. Like there is a standard for corrections which is called NTRIP. So if it supports that standard, I guess there could be an easy bridge, like of a standard protocol already supported. But that's normally not directly via QField. You'd rather use like another app, because even though it's a standard, it's not so standard.
Yeah, I don't know. Yeah. You will have to speak to them.
Yeah, interesting. So we can certainly look at that.
Yeah.
Thanks.
Other question? Just one question. It's a silly one. How do you choose the release name? So I see Matterhorn and Arctic Fox.
Yeah.
What's the...
So back in the days, we used mountains, and then we switched to animals. So right now we are in animal mode, and it's like the starting letter just counts up in the alphabet. So that's basically, and then we just internally look around who like gave the most ideas for the current release, and that's the person who has to choose the release name.
Okay, so it's who decide to vote? Who decide to vote? It will be the developers, or?
It's mostly within developers, yeah. But if you have a good idea, don't hesitate to drop by our booth and suggest a name for the next release.
Platypus. Any other questions? Thank you very much, Matthias.
Pleasure, thank you.
So there is a lunch break from 2 up till 2 o'clock, and the next session will start at 2 o'clock here. Thank you very much.